files, except for the lib file, the executive.lib, and I pulled together a header that, if we look at executive, it has a header, NoSQLDB.h, that pulls together all the other headers. So all you have to do is pound include NoSQLDB.h and make a reference to the library, and you're done. You don't have to add any of those parts into your project or anything. Okay. So ideally, if Visual Studio put all the header files up in the project directory, then these would all be you'd just be naming the header files, and deployment would be really easy. And I had intended to create a set of header files all to put in a deployed directory without those relative paths, but I ran out of enthusiasm toward the end. Okay, so I was ready to be done with this project. I really enjoy writing code, but you do it long enough and you need a break. So I didn't do that, but I think you'll find it quite easy to deploy if you do that. Simply take my zip, unzip it. You'll get a lot of stuff that you don't need, the project files and blah blah, solution, all that. But it's okay. You just to get the directory structure where you need it, with the header files where you need it. So, and then link to that lib file. You make a dependency to the lib file. So in order to test that, what I did was I created a test application, and notice here's the test application. It has no header file, so let's look at test application. What does it do? It includes the NoSQLDB.h that's going to pull in all the other files, and it includes a payload, because any application will have their own application-specific payload, okay? And then it just uses them, So if we set this as startup, and run it, it's doing the right kind of stuff. This is just a little demo. This isn't a complete test. It's just showing that test application, just all I did was I made a reference. If you look at references, there is a reference to executive.lib, okay? And the header files, it includes, whoops, looking at the wrong one. The header files, it simply pulls in. It doesn't have any of its own. It simply pulls in the executive NoSQL.db and pulls in the payload, okay? So that just demonstrates that an application can use this without a problem. Now, part of the issue is there's a lot of parts here, so it may be, so how on earth do I wrap my arms around this? Well, you probably are 90% of the way there already, simply because you built your own. But if you look at, this is my test class running all of the, it's demonstrated it meets every single one of the 13 requirements are all here. And now if you go and look at that test class.cpp, you'll find, how do I create a database? Here's code that does it. How do I add and delete key value pairs? Code that does it. How do I edit relationships? Code that does it. How do I edit, blah, blah, blah. So this test class, it was my requirements testing, but it's also an executable document. You can run it, but you can see what each of the code, each thing does. So it's a really nice documentation. You don't have to write another user. You don't have to write a user manual. It's right here. Okay. So if you elect to use mine, there's that. Again, if you can use your own, you're encouraged to do that. The other thing I want to show you is this process class. So what the heck is this? What's going on here? So let's pull this up and let me run it. So I just popped up Notepad and showing the code from this process class. So you have a requirement in Project 2 to show code. Ta-da. Okay. So, and also notice, so here I am, you know, this is the parent process writing on its console, and now this is the child process, which happens to be Notepad, and I gave it a command line asking it to, you know, so I'm starting the process C Windows System 32 Notepad, and then Notepad has a, if you give it /A, that says I'm going to try to load an ASCII file that whose path occurs after the space from A, so I'm loading process.h. You know, you could name any other thing you wanted to, okay? So now, when I kill this guy, I just notified the parent. I've got a little notification scheme that notified the parent about that exiting. And so, you know, piece of cake. Not very big. I've tried to make it clear, you know, I'm using the Win32 API to start the process. So this is a lot of, these are all defined in Windows.h, you know, and stuff like that. And I'm trying to show you, when I call this create process, I'm trying to show you what each of these things are, okay? So one thing I did here, I provided a parameter wherever I did it. Where the heck did I do it? I forgot where I did it. Anyway, doesn't matter. So, you know, you're welcome. You're invited to take a look at it if you have questions. Maybe asking about that in the help session on Friday might not be a bad thing to do. So with that, let's go to the lecture proper. So, so our focus today is on inheritance, and I want to talk about some specific problems that arise, things that you can do wrong with inheritance. So let's pull up this errors. There's a couple of things that, let me go to hiding one and pull this up. So startup. There are a couple of problems that you can get into with inheritance that this illustrates. So for a good part of the period, I'm going to be talking about quirks of the C++ language. There are several things that, if you don't handle correctly, can cause unexpected behavior. But it's a surprisingly short list. For such a big language, it's a quite short list. And I am going to give you the whole list, everything I know about today, in a document that's about 4 pages long. Okay? But this is going to begin the presentation. So Stroustrup, if you read him carefully, says, overloading is the use of the same function identifier for different functions declared in the same scope. So if I overload a base class function in a derived class, I violated that. I violated that because they're different scopes. Okay? So let's see what that means. So here I have a base class that does an overload of the process function for ints and doubles, and there's no error here. This is fine. Not a problem. And here is the derived class, and I overloaded the process class and the derived class, and this is a defect because it hides the base class functions. It has to do with the way the compiler handles its symbol table. Okay? This process overload hides those other two. Now, I can get the compiler to show them by saying using base : process, now they become visible. But you won't remember to do that. So the moral of the story is don't overload across class processes. Let's look at this and see what happens. So here in the derived class, I have overloaded this process function, okay, and now let's come and use it. So here I'm using the base class. Everything works fine. Here's a process for ints, process for doubles, and I have a little ID function, just to help me illustrate stuff. Now I created a derived class, and now d.id.process works fine, but this is hidden. So let's uncomment it. This is a hidden function. So now the little squiggly is telling you nothing wrong other than that this is overloading a base class function. So this function is. So let's build it. Builders. Derived process, too many arguments in function call. Derived process function does not take one argument, okay? It's complaining about this guy right here because he's hidden. He's there, he's inherited from the base class, but he's hidden by this overload. That's what it means to make sure you overload in the same scope. So this is a defect in the derived class. I overloaded in a base class function in the derived class. So let's comment it out. Just going to comment it out. And bingo, compiles and works. Okay. Now I could come in here. Let's uncomment this. And I could where did I do that? I could do this. And now it builds and works. But the issue is that you won't remember to do this. You won't remember to do that. So it's easy to remember, do not overload across class scopes. This is a little Band-Aid. If you did the wrong thing, it covers over the wound, but the wound, don't do it. You don't need it. Remember that overloading is just syntactic sugar. Nothing essential about it. They're separate functions. I can have another function, just give it a different name. Okay? Yeah.
If you happen to uncomment line number 64, then both the versions...
If I uncomment what?
Line 64.
64. Uh-huh. then both functions are visible. Yeah, because it says, what? Let's see, this unhide both base class members. I just illustrated it for one, but I could uncomment both. So that's a defect in the base class. Now let's look at hiding two. Now in hiding two, I've overloaded a virtual function, and that is a defect. Nothing wrong with the base class will operate effectively, but here's what happens. Now, if I override it in the derived class, okay, that hides the base process functions. So here, the defect is not because this is a perfectly valid overriding of the virtual function. Perfectly valid for me to override a virtual function in a derived class. The defect is in the base class. I made I overloaded virtual functions, and so now when I redefine a virtual function, that hides the other virtual function in the base class. So for example, here in the base class, I have a process int and process double, and now, both, they're overloaded virtual functions, and now if I redefine process int, that hides the process double. It'll still compile. But now, when I call on the derived 3.5, the compiler is willing to convert that to an integer. This is hidden. So now the double function is hidden, but the compiler looks at that and says, oh, I have a process that it takes an int, and so I can convert this 3.5 to an int. So now, everything is compiled, running, and you say, oh, okay, but my data isn't quite right. What's wrong? I'm not getting quite the right values. What's wrong? Here, I can find it because there's only 43 lines of code. But if there's 6,000, are you never going to find it? And you got this almost right data. It would have been much better if it was a compile time failure. Or the compile time failures are the best. The next best thing is some runtime exception, but that doesn't, just silently goes away and makes this little conversion to your data. And so you get answers that aren't quite right. So your landing vehicle, when it comes down, is going a little too fast and bang, crashes. Okay. So don't go to work for NASA if you're gonna write code like this, okay? So, or you're building an autonomous vehicle car, okay? Boom, boom, boom. Okay, rear-ending people. Why is this happening? So let's run it. So what's happening here is, so it says 3.5, and so I run this, and my base object invoking base process int, base object invoking process double, and that's just recognized by type inference on this. But now no type inference because the double is hidden because I overrode correctly in the derived class the process int. So now I have derived int, and I supplied them both with 3.5, and they I've supplied the int one with 3, and I supplied the derived one with 3.5, and it just happily converted it to 3. Truncated, okay? So the moral of the story is, do not overload virtual functions anywhere, any place, anytime. Do not overload across class scopes, and do not overload virtual functions. Nice, 2 simple, easy to remember rules. Okay. So, hiding. Importance of virtual destructors. Code virtual destructors. Virtual functions, I think that's what it was. Yep. So the issue here is, let's pull up the virtual function pointer table. So here, because I have a virtual destructor in the base class, there is a slot in the virtual function pointer table for the destructor. And when I derive D from B, it inherits B's virtual table, and then because there's another method, it adds the additional method. Okay. I didn't really have to declare the MF2 and D as virtual, because once it's virtual, it stays virtual down the inheritance chain. But I think it's a good idea always to provide them, because a maintenance programmer may not be looking at your base and doesn't understand. You need to tell them, clearly this is a virtual function. But anyway, so now if I'm pointing to the base class with a base class pointer and I call delete, let's suppose I create it on the heap and I call delete on that base class pointer, because I made these virtual, I'm going to bind to the derived destructor, okay, which will run, and as its first act we'll call the base destructor, so that both get destroyed. But if I didn't make this virtual, there is no destructor slot in the virtual function pointer table. And so now when I call delete on a base pointer, it says, oh, there's no slot there, so I have to bind to the base destructor, and that's all it calls. Even though I'm pointing to a derived object, it'll just call the base destructor because you didn't make it virtual. So let's look at the code and convince ourselves that that actually happens. Okay, so I've got this base DB for defective base. I don't make the destructor virtual. And here's DD, defective derived class. I'm going to redefine a non-virtual member. So in the base class, I have a void non-virtual member function, okay? And here, I am redefining it in the derived class, but it's non-virtual, so it doesn't have a slot in the virtual function pointer table. And so if I have a pointer to that derived object, it will correctly call derived virtual functions, but it'll call the base non-virtual function, even though you redefined it in the derived class. Let's run it and see what happens. So here, what I'm doing is, first, I declare these a base and a derived on the stack frame. I'm just creating an anonymous scope to force the destructor to be called. And they both work correctly because I'm specifically saying derived. So the compiler knows there's a derived object and correctly calls the derived destructor. But here, when I create it on the heap, so here I have I create a base object on the heap and call the virtual function, non-member function, and the destructor, and that all works correctly. But now the derived object, this derived virtual function works correctly. The non-virtual function is incorrect. I'm going to call the bases because I'm pointing to it with a base pointer, db star, okay? db is the base type, defective base. So I'm pointing to it with a base pointer, and when I call that non-virtual member function, it won't call, it'll call db colon non-virtual member function called on the dd object. Okay. which is exactly what it would do if I'd never defined it in the first place. But the point is that if you've defined it, you expect it to be called, and it ain't going to be called. Okay? And when I call the destructor, it's not going to call the derived destructor. So the base part works, the derived part doesn't. Let's run it. So, so everything works fine on stack. Now here's my heap, and notice here's my base. Here's my base, and everything. Everything is being called on that base object. Now I'm pointing to this derived object with a base class pointer, and here's my base constructor, here's my derived constructor, because I am constructing it. Now here I call through that base class pointer virtual member function. So I'm calling the, well, let's look at this one. Put this one aside for a minute. So here I'm pointing this with a base pointer. So here I'm creating the base and derived parts. And now dd of the virtual member function, I'm calling the correct one. But now on the non-virtual, I'm pointing to a derived object, but I'm calling the base member function, non-virtual member function, even though I redefined it in the derived class. So I'm not calling the function that I wrote for that derived class in the derived class because it was non-virtual. Non-virtual means it's invariant, don't change it. And now here's the destructor. Notice I only call the base destructor. Okay. So, yeah.
In similar manner, when we have our base class pointer pointing to the derived class object, if I write a new method in the derived class, which is
everything works. You can as long as if you create a virtual function in the derived class, if you create a virtual function in the base class and redefine it in the derived class, it works. If I create a new function in the derived class with that base class, I don't have that. What will happen is I'll get a compile time failure, okay, because I'm pointing to it with a base class function and it's non-virtual. Okay, so it says I don't know about that.
Basically, it's not in the scope
of that interface pointer. Yeah, that it's not just that it was whether actually it's not a question of whether it's virtual or not. It's not in the base protocol, so you can't call it. Okay. Yes.
So you basically always want to declare destructor as virtual in the base class?
Provided that it will be the base for any inheritance. If I'm never going to inherit from it, I don't have any virtual functions in it, then you don't need to declare it virtual. But if it's going to be the base for anything, if it could be possibly the base for anything, you should make it virtual. Okay. The only place that you don't have a problem if you're just doing stack-based stuff. The only place you get into a problem when you have a non-virtual destructor is when you're pointing to that object on the heap with a base class pointer and you call delete on the base class pointer. If I have a derived class object on a stack and it goes out of scope, it'll work fine, just like I illustrated. Okay. So for example, on rare occasions, I will inherit from string because I want to add some functionality to string, and string doesn't have a virtual destructor. So that tells me I'll get correct operation as long as I don't point to that, I don't create an instance of my modified class on the heap and point to it with a string pointer. Now that would be kind of dumb, but okay. So, So virtual destructors don't, so the moral of this demo is if your class has any virtual functions, declare the destructor as virtual, and do not redefine a non-virtual function in a derived class, do not redefine in a derived class a non-virtual function from the base. Neither of those work correctly. Okay. So now let's go over my list of dark corners. This is the whole list. So dark corners are places where you can unsuspectedly make errors. Okay, they don't seem like errors, but they are. Okay, so and this is the entire list of these dark corners. There's 3 or 4 pages here, the entire list, which is a very small list for such a big comprehensive language as C++. It's surprising that the list is this small. It's not surprising that you have a list. All the languages have a list. You know, C# and Java have this destructor thing that I'm complaining about, and the fact that you can't copy instances, and you know, there's tons of dark corners there. So, so here, compiler will generate certain member functions. If and only if no constructors are declared, the compiler will generate, if needed, default blah 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 blah. Okay, so it tells you when it'll create the default, when it'll create copy and assignment operators and destructors. So for each class you design, you should decide to let the compiler generate if correct, and they will be correct if and only if the bases and the members of the class have correct construction, assignment, and destruction semantics. Okay, so otherwise you must either implement them or make them inaccessible by making private or declare equals delete on each signature. So so this is not so much a this is a dark corner in the sense that if I have a class that's holding a pointer to something on the heap and I don't create constructors and assignment operators, then the compiler will generate them for me and they're wrong. It'll assign the pointers, not what they point to. Each constructor may be initialized with a list. When a constructor is called as its first action, it calls a constructor. We've seen that if you don't use an initialization list, it's easy to write derived constructors that do a void construction on their bases. Okay, that doesn't happen to you if you use an initialization list. Initialization list tells the compiler, I want you to initialize my bases and my members this way. Always better. Once you define a constructor, the compiler's attitude is you're taking over the whole job. You got to do the whole job. Overriding. Avoid redefining in derived classes non-virtual base class functions. Overloading. Avoid overloading non-virtual base class functions in derived classes. Avoid overloading virtual functions. Now here's something we didn't talk about. Avoid using default parameters in virtual functions. So here's what happens. There is a virtual function pointer table, but there is not a virtual parameter table. So if I provide initial values for the parameters in a base class, and I provide a different set in a derived class, If I create the derived class instance on the stack and just invoke it, it'll use the derived class initialization, for those parameters. But if I point to it, if I create an instance of the derived class on the heap and point to it with a base class pointer, there is no virtual parameter table, and so the compiler will assign the base class initialization of those parameters, not the derived class. So either don't use initialization parameters in your class hierarchies, or make them all the same. That'll keep you out of trouble. Better not to use them. But if you feel like for the user convenience, it's really important for me to do that, you do it for all of them and make a big note for the maintenance developer. You have to use the same initialization values in the derived classes as you do in the base. Okay. Always provide a virtual destructor if your class may be used as the base class for derivation. Multiple virtual inheritance of implementation has this initialization problem that when I merge, so I've got an A, B and C derived from A, and D derives from both of those. So when I merge the A, without virtual inheritance, I have an A in each part, B and C. But if I use virtual inheritance to merge the A, now that can only be initialized one way, and if B needs it one way and C needs it another way, I can write correct code that breaks incorrect code. So I don't use virtual inheritance. I think it's too risky. So, 1 second. I'll be right with you. So, I'm defining overriding and overloading, but this is the end. That's my whole list. Okay? My whole list. All the dark corners that I know of in the C++ language. But these can bite you. You can be surprised. And so you really need to make these your own. Again, you should have that skinny notebook that you put under your elbow when you're writing code, and this should be in there. Question? Was there a question?
Oh, yeah. I remember last time you say that if a class have no copy constructor, assignment, and destructor, it will generate move constructor by default. Right?
It'll generate all of them by default.
All of them?
All of them. If you need them.
Huh?
So if you write code that implies that operation happens, then the compiler will generate. So it won't generate it if your code never,
Yeah. So if you need them, it will generate all of them.
Yep.
Okay, not only the move constructor.
Yep. But if you define any one of them, none of the move constructors are defined.
Okay. Yeah, got it. Yeah.
So that's the whole list. Now, make sure you're comfortable with these definitions. So these are just definitions in this last page. Overriding means that I provide in a derived class a declaration and definition of a virtual base class function using exactly the same function signature and the same or covariant return type. The covariant return type simply means if I have a base class virtual function that returns a pointer or reference to the base class, I can override that in the derived class and return a pointer or reference to the derived class. But I have never used that because if I'm creating virtual functions, almost always I want to point to them with a base class pointer. So, but that's the definition. Overloading, provide in the same class or in the same global scope a function in the same class or the same global scope, a function definition that uses the function identifier of another existing function for a different sequence of formal parameters. Okay? You can't overload on return type, because the client isn't compelled to use it, and so the compiler won't be able to tell in some cases. So that's the whole list. Those are the dark corners. Aren't any more that I know of. Okay? Cool. Now I want to show you something interesting. Non-virtual interface, so I want non-virtual interfaces. So non-virtual interfaces. Something interesting going on here. Here I have a class, non-virtual interface, that defines a non-virtual method. It's the only non-destructor method in the class. It's not virtual. Okay, that calls two functions, do first thing, do second thing, and the two functions are private and virtual. Private and virtual. And now in the derived class is going to inherit the non-virtual do something method, and it redefines the private do first thing and do second thing for the derived class. And you say, that can't possibly work, they're private. Derived class doesn't have access to private stuff. It only has access to protected stuff, and that's correct. But there's a difference between accessibility, what I can call or access, and visibility. The compiler sees those private virtual functions and will happily override them. So now in my derived class, I inherit do something, and that do something calls do first step, do first thing, but it's going to call the derived do first thing. Okay? Even if I point to it with a base class pointer. So here, what I'm going to do is in my main, I'm going to say I'm going to create an instance of the base and P1 do something, and then I'm going to create an instance of the derived, and I'm going to point to it with a base pointer, okay, non-virtual interface pointer, P2. P2, do something, and let's watch what happens. So, can I? Do something by calling. So this is the base instance. Do something by calling private virtual functions, doing base first thing, doing base second thing. Do something by calling private virtual functions, doing derived first thing, doing derived second thing. So it works. This is a design pattern. We talk about this in the design patterns class. It's called the template method pattern. And here's the idea. This method, non-virtual public method, is called the template method. And it lays out an algorithm in steps. Step 1, step 2, step 3, step 4, step 5. And the base class then defines those private methods, and it may make some non-virtual, which says don't change this step in the algorithm. It may make them virtual, which says you may but don't have to change this step in the algorithm. And it may make a step pure virtual, which says you must provide a definition. So typically that would be a case where the base class just didn't have enough information to implement that step of the algorithm. Okay? So we have the designer has a lot of control over that algorithm. So now a user can come along, create a derived class, and change all the parts of the algorithm to suit his application that should be changed. And any that shouldn't be changed, he won't change. Okay? Nice scheme. So a lot of people look at this, can't possibly work. Can't possibly work. Those are private. But the difference is, there's a difference between accessibility. Notice my derived class can't access those methods. Do first and do second. Can't. Okay? They're private. But indirectly it accesses them by calling the non-virtual public function, which in turn accesses those methods. Okay? So it can't directly, private says he can't directly access them, but he can access them through that public member function that he inherits. So, cool. So that's my stupid code trick for the day. Do any of you watch David Letterman, or did any of you watch David Letterman when he was doing his show? So he did these spots called stupid pet tricks. You know, he'd have a video or something, some really inane, dumb, thing that would get people to laugh. It was a stupid pet trick. Well, this is my stupid code trick. But it's not stupid at all. It really is a good idea and useful. But just kind of unexpected. Okay. So good. Now I want to talk about Liskov substitution. So this is kind of tying together what we're doing with inheritance and polymorphic structures. So let's go to the Liskov substitution principle. So functions that use pointers or references statically typed to some base class must be able to use objects of classes derived from the base through those pointers or references without any knowledge specific to the derived class. That's the ignorance principle. So that says my clients just have to know the base class protocol. They don't have to know anything about the distinctions between the derived classes. So for example, my graphics editor. I have 10 million lines of CAD code above my editor, and in my editor I have the shape object, or graphics object, from which I derive line and circle and rectangle, and now I can come along and add a polygon to that and not break anybody, because polygon is a graphics object. Okay. So, and the users don't have to have any knowledge specialized. Is this a point? The display list didn't have to say, if you're a point, move like a point. If you're a line, move like a line. It just said, move, 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 move. Cool. Substitution failures. A hierarchy of classes will fail to satisfy this principle if any of the following are true. The base class does not make its destructor virtual. Derived classes redefine non-virtual member functions of the base class. Virtual functions are overloaded or given default parameters. All substitution failures. Okay? The other error that we saw, overloading across class scopes, is not a substitution failure, because we weren't dynamically dispatching, they were non-virtual functions. So these are substitution failures. Clients use dynamic cache to access derived class extensions to the base class protocol. So this isn't an error, but it's throwing away. It's a substitution failure because we're throwing away that ignorance when we use dynamic cache. Because now we have to know the derived class protocol in order to use that extension. Now, there can be subtle failures. Bob Martin, so I took some of this principal material from a couple of papers that Bob Martin wrote. So Martin points out that substitution failures can happen for subtle reasons, and he used the case of a square and a rectangle. So everybody knows that a square is a rectangle, right? But it is an error to inherit from rectangle to define your square, because the square class has a stronger contract than the rectangle. The rectangle says I can vary in either direction. The square, if I vary the width, the height changes. If I vary the height, the width changes. Okay, so that square is not a rectangle, because a rectangle I can move in either direction. Okay, so this is a conceptual failure. Okay, it really is a failure. And there's one way of looking at it is that a derived class is not allowed to make the contract stronger for the base class. Okay, it's got to satisfy all the conditions of the base class to be an ISA. Another giveaway is the fact that in this case, the square throws away some of the member data. In the base class, I needed both height and width. But now in the square, I can use either one, throw away the other. Okay, I'm not using it. That says that something is going on. The contract is different. Okay, so okay. So let's stop with that. Okay. Where are we? 10:26. I might move ahead a little bit. I didn't with a. Let me. Let me. Talk about a couple of things here. This is the command, something in design patterns we call the command pattern. And the idea of the command pattern is this. We have some set of events that's happening. So all this code above the dotted line is library code. All the code below the library dotted line is client code, application specific. So here's a library we wrote 10 years ago, and now we're using that library today to build this application-specific code. Some event happens here in this library, and I want to know about it. My client needs to know about it. So if the library defines an invoker and a command interface, this is, I call a hook, okay? I'll tell you why in a minute. So what happens is that when the event happens, the invoker is going to call the operation on that interface. It's going to call it on any derived object that's bound to that interface. So here, the client knows, well, what the client knows about is that there is this event that's happened, and that this method will be called when that event happens. That's all he knows. He has to know this interface. That interface has to be available to him. And so he derives from that interface, and now he defines what execute does. So when that event happens, I get to do my thing. The library couldn't possibly know what every application, because every application needs something different. When a button's clicked, what I want to happen. The library can't possibly know what to do when a button's clicked. My code does, but I have to know that button was clicked. And so using the command pattern, I simply derive from that button click command. Okay? And I do something here, okay, on my body. So a nice use of command pattern. And now what this means is that my library can support an open-ended list of applications that need to respond to its internal events. It needs an invoker for each kind of an event or some way to notify. Either there's some structure in here with different interfaces or separate invokers. It doesn't matter what you do. In .NET, we use delegates. This is essentially a delegate structure. And we use a delegate, and for each event, there's a separate delegate. Okay, but anyway, so now we can support this open-ended list of, so really, really flexible. My library has an event, I can respond to it. Okay. Flexible, flexible, flexible. That's why we're here. And there's some code there. You know, you can go pull up the code and look at it and blah, 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 blah. Okay. One other thing I want to look at, I want to get to this runtime type information just as the last thing we do. I want to talk about, so suppose that I had two separate classes, apples and oranges. Don't share a common hierarchy. And I want to do polymorphic operations on them. We can't do that, right? They don't share a common hierarchy. How can I do polymorphism if they don't share a common hierarchy? The answer is I can, with another stupid code trick. Okay? Here's what I do. Where did my heterogeneous list? So here's what I do. Boy, that's hardly visible. I should have made the lines darker. Can you guys, can you see that okay? You can see the lines? So here's my apples and oranges, and they don't share a common hierarchy. And I want to do polymorphic fruit operations on them. So what do? I get sneaky. I create HBase for heterogeneous base. These are heterogeneous objects. They don't different types that don't occur in the same inheritance hierarchy. And I pull them into a common hierarchy by using this base. And now I write a little apples2 wrapper that simply does, guess what, multiple inheritance between apples and HBase, and between oranges between orange and HBase. So now apples and oranges are on this single hierarchy, and I can do polymorphic operations. What a great question, interview question. Okay? So I can do polymorphic. Now, understand that these have to be similar enough that a common language makes sense for the two, because that's really what I'm doing. I'm providing a common language to call operations on those two. And so they have to be similar enough that that common language makes sense, but as long as that's the case, I can make them polymorphic. Absolutely. Even though they don't, they don't belong in a common hierarchy. There's a pattern, something like this in design patterns called the adapter pattern, which lets us bring something that isn't an inheritance hierarchy into an inheritance hierarchy. Really useful scheme. Here, I'm just oh, this, I'm just building a list of these. I'm building a polymorphic list of these, and then I'm running down the list saying, you know, do your thing, do your thing, do your thing. This is sort of like the display list, and these are the graphics objects. Think of it that way. Okay, and there's code here. You can look at it. Okay. So this was this. Yes?
What if each item directly inherit from apples and oranges? What happened in that?
But now, so I don't have a common base class, okay? So I could see what you have here. If I inherit from both of these, you have a fruit class. You don't have an apples class. You don't have an orange class. You have a fruit class, okay? And you have those two. And you can't, you know, now you've lost the ability to make an interface language that makes sense for the two different types. Our goal here is to really treat those two as two different types, but polymorphically. So we see their changed behavior, but we don't have to realize which one we're talking to get that changed behavior. Okay? But if I just inherited from both of those, I would have to. Do you use this all the time? Rarely, but every once in a while. You know, again, the adapter pattern we'll see in design patterns. If you take design patterns, yeah, that's what we're doing. Okay, so one last thing I want to talk about, and then we'll go home. I want to talk about runtime type information. So this is as close as C++ gets to reflection. And it's very weak. Useful, but it's anything but full reflection. So I have a function, type ID, standard type ID, that returns a type info object, standard type info object. And what's in the standard type info object, I can compare two different type info objects to see if they came from the same type. I can, or see that they didn't come from the same type. I can compare for equality or inequality. Before says, are you my base? Okay. And I can get the name of the class. And I've used that quite a bit in some of our code, just to illustrate, so you see what's happening, you know, which class is being called and stuff. I used that in the, I don't think I showed you, but in the, yeah, I'll show you as soon as we're done here. I think we'll have a couple of minutes. In the, Nag remind me, Naga nag me, as soon as I'm done with this, I want to show you in my solution to project 1, I've used this type ID, and I'll show you where. So, so I can get the name, and so now I can do these sorts of things. I can say, if I have class foo, I can say type ID foo.name, and that returns foo. If I declare a foo pointer, I say type ID pointer.name returns foo star. And if I say type ID of the contents of pointer, that returns a foo. Cool. And if I have class derived from public base, type ID of base dot before type ID of derived returns true. So I can tell, is this a base of that derived class? Okay. And so here, you know, for example, here I'm using this on the graphics editor, and so, you know, shape pointer to a shape pointer equals new circle. and type ID of shape equals type ID of contents of SP returns false, because a circle is not the same object as that graphics. Type ID shape.before type ID returns true. Type ID sp.name returns circle star. Type ID pointed at sp.name returns circle. So I'm polymorphically getting the right name. Okay. But that's it. No, I can't get methods. I can't get properties. I can't get member data and stuff like that, like you can with C# and Java. That's the whole schmear. Now let me show you where I am using that. So if I pull up the my solution in NoSQLDB, and here's the test class project, so let me just run that. So at the end, in requirement 10, it said you're required to demonstrate that you use these packages. You're required to use these packages. So notice I'm printing out DB core, edit, executive, payload, persist, query. I've got those packages. They are there. And how did I do that? Let's come to requirements 10. Oops, almost killed the wrong thing. So let's go look at requirements 10. So here I'm calling DB core payload identity, edit core payload identity, executive.identity, payload.identity. So let's just go look at persist. So persist has an identify, and here's a I lied to you. I'm sorry. I lied to you. I'm not using type ID. I could have, but I'm not. What I'm using is a macro called __file__. This is part of the standard C++ language. These macros are defined in C++. And so, so now when I call persist identify, this is just printing out the file that this function belongs to. Okay, and that's why I got that. So.
I think you used for equipment 1 or 2.
I did use type. I have used it. I know, but I forget where. I write a ton of code and I forget. If I didn't write it 2 days ago, I forgot where I put it. Okay, comes with my ancient fact that I've been around too long. Alrighty, so. Avoiding the dark corners will almost certainly appear on the midterm. And the Liskov substitution, there's 4 principles. Liskov substitution principle, open and closed principle, dependency inversion principle, and interface segregation principle. And each exam, I put a question about one of the principles. Oh, they're different. There's 4 exams, 2 in the first class, 2 in the second. So 1, 2 for them, 3, 4 for you. Okay, and there'll be a question about one of those 4 principles that says state the blah 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 principle, whatever it is, but then and discuss how and where you used it in project 2. And the idea is, I don't care a fig if you memorized or wrote down on your note sheet the definition of the principle. If you can't use it, it's worthless. So I'm asked that second part of the question is to demonstrate that you know how to use that principle. Okay. Alrighty, so on Thursday we will talk about the open and closed principle, and we're 1 lecture behind. I'll try to catch up and talk about the dependency inversion principle as well. And there will be a help session on Friday. Anybody that needs to use my NoSQL database is welcome to ask questions about that again. You know, I've tried to make it as easy as I can to use it. So, any questions before we break? I've either been very, very clear or very, very opaque. I hope it was the former. See you all. There will be an open help session this afternoon as well at 2 o'clock, as always.
去年考试，就是那个
最后那个。
bonus 就是那个 status 那题不是没问题吗 ？status 到底是那个差那2那个啊，对，是真的说是老师没给2，然后对大家都大家就应该知道那地方指出了，估计是没给大家回头给分儿。
你说在哪儿？不知道。
哪办公室？哎，等我一下，我也不知道在哪。
他是在 Luminary 里面也是。
哦，不是 virtual 就不行，因为是 private。
啊，是它这个特殊，它会有特殊在 private。
他说的是是的，应该是
我有2个，这个因为它一开始是不在里面，这个上面它一开始只有但是你这个是用水的讲的，所以说你就知道这2个对应到词的多少。这是说那个列表，所以就把它修正一下。
有一个那啥会让你在一个在上面，就可以在上面留下，就是一张小抄，而且它是
下一个。
没有啊，但是我上过他的，
是这儿吧
应？该都一样。哦，对对对，是这个。那是什么？讲这几个。是这几个函数。
没有呀，13国也挺老的，13国也开了。
你是实习吗？
的时候。做安全。他说：“你这什么？OD。”
Don't worry about it. Ocean. We'll just ask him next. paper for